So we talked a little bit about two-dimensional level curves, and we use that to help us inform about the plot of a three-dimensional plot when we took the output of a two-dimensional function and plotted that with the input. But if we have a three-dimensional function and we tried to plot the output with it, well, that gives us 4 parameters and gives us a 4D graph. So if I have something like this w equals f of x, y, z, well, now I have 4 parameters, and that's not very helpful for graphing on a 3D graph. So what we can do is generate this idea called a level surface. So for that w value, if we set it equal to 1 or 2 or 3, we now have a function of really just 3 variables, and we can solve for z and then plot x, y, and z together. So let's look at an example. I have this function f of x, y, z equals this fraction. And if I set the output equal to some number, we'll just call it a here, and then that gives me this, and then I get z squared by itself, that gets me this, and then I solve for z proper, that gets me z equals plus or minus this square root. So then what we can do is we can hop on over to a plotter, and we can look at this graph. Notice in this case, I've set a equal to negative 1.5. So if I'm trying to get the output of the function to be negative 1.5, what I see is I can choose values from this paraboloid to get it. But what I also see is if I want more negative output, I kind of have this stretched paraboloid that allows me to get those values. And then if I'm moving towards smaller negative values and get down to 0, if the output of the function is actually 0, I have this weird kind of these lines where z just goes and goes, or I have these functions where z is they're basically lines. Z is a function of y, but they're parallel to the x-axis. And so then, as they go positive, something changes again, and they start to resemble cones. They're actually parabolic, but they start to resemble cones. And we can see how those change as we move. And if I wanted to, I could animate that. I could walk through the particular pieces and see how it expands and contracts and see as it changes over. But the idea behind a level surface is being able to see what sort of inputs you need to get specific types of outputs. And what we notice is that the types of inputs that get us negative values look dramatically different from the types of inputs that it takes to get positive values. And that tells us that there's what's called a bifurcation, that at some point the shape changes dramatically based upon this parameter. But anyway, that's the fundamental way to approach level surfaces, is set values and then solve for that. I recommend a lot of times using computer algebra systems. It's nice to be able to do it by hand, but it can be extremely time consuming. So, use some algebra skills and some ingenuity here.